Check, check. All right, guys, it is almost 6 o'clock. We're almost ready to get started. Check, check. Testing, testing. Okay. I believe everything's set up. Okay. Excuse me. Let's do this. It's time, folks. It's time. All right. I have been preparing all day for this. Here, hold on. Let me scale this a little better. There. I feel like that's a little more size appropriate. All right. Okay, guys, we are going to continue on with our study. And today we're going to talk about public safety and healthcare. Yesterday we covered the study guide material, and today we're going to be going over flashcards. And those flashcards are going to dictate how much more studying I need on this sector. Now, public safety is one of those areas where, yeah, it's going to be on the CBET test and it might not account for a huge amount of the percentage. However, this is information that you're going to need going forward in your biomed career anyway. Unlike maybe anatomy, physiology, and some of the other stuff, which are niceties, public safety and healthcare facilities is going to explain a lot about what happens and why it happens. All right, and if you ever want to take the CHTM, guaranteed that this is going to be one of the hotbeds for the CHTM, Certified Healthcare Technology Manager. So without further ado, let's go ahead and let's flip some of these cameras around and let's take a look at our first card for the night. And you can see I've got my notepad here, Because if there's something I don't understand, yes, I'm going to pull it up so that you can see it with me. But also, I'm going to write it down because it's something that I'm going to have to study more of, apparently. So, the very first card right here, it says, give an overview of the NFPA 99 policy on storage of gas cylinders. Ooh, okay. Well, this was one of the first topics we covered yesterday. And for cylinders, it basically says that they are separated based on their properties. So oxidizers have to be kept separately from flammable liquids and gases. And inert gases have to be maintained. Everything has to be labeled. Cylinders with a certain size, I think it's 36.5 cubic meters and larger, they have special precautions for those. I do know that oxidizers, they have to be either affixed to carts or to equipment. So they can't just be laying around. But let's go ahead and let's see what the correct answer is. Oh, geez. Yeah, that's a lot, guys. It says, NFPA 99, section 11.3 defines proper storage of gas cylinders, requires full medical gas cylinders as well as containers greater than 85 meters 3, so 85 meters cubed, at standard temperature and pressure, should be stored separately from full containers and non-combustible lockable secured spaces. Containers of non-flammable gas ranging from 8.5 to 85 should be stored in a secured non-combustible or limited storage space. This is one of those questions I'm going to get wrong. Like, they're shooting numbers out there with certain cylinder sizes. I can tell you the cylinder if I've seen it in person. I could probably tell you how big it is, but remembering like which ones have to be locked down and stuff, I won't get that. And probably neither will any of you. It says that containers of non-flammable gas must be stored separately from any flammable gas, liquid, or vapor by a minimum of 20 feet or 5 feet of storage space if protected by an NFPA compliant sprinkler system. And no additional separation if combined with other sources of ignition are prohibited in interior storage spaces. Must be kept a minimum of 20 feet away. Small Class A, B, D, and E cylinders must be secured to a stand or other equipment designed to hold medical gas cylinders. I'm probably going to get that one wrong. And I'm okay with that. There's certain questions I was like, man, if they get into like cylinder volumes and stuff like that, no way. I won't get it. All right. Next card, I'm going to go ahead and just throw these off to the side. I don't like compressed gases, if you can tell. Describe the NFPA 99 requirements for electronic nurse call systems. Ooh, okay. Okay, so the requirements for nurse call systems, they have to be periodically inspected, and nurse call systems are they have to have a visual indicator and an audible indicator for an alarm. And I know that it's for not only staff and patient safety, but it's also for when patients have a request. So I don't know what the correct answer is going to be on this one. If this was in multiple choice, for sure, I would probably nail this one, but you know, describe the requirements for electronic nurse call systems. Jesus, they probably write entire books on that. Okay, let's see. Nurse call systems in accordance with NFPA 99 are used to communicate with patients and staff via marked audiovisual, tone-visual call systems. The systems must provide notifications for medical device alarms, staff emergency calls, code calls, and or staff and patient requests. The systems must also announce both audibly and visibly each call made to a relevant area in accordance with state and local codes. Okay. All right. I was close on that one. Next, Mind you, there's quite a few cards in this category, so if I'm going through them kind of quickly, that's why. Describe the NFPA 99 policies on plug-connected portable non-medical electronics. Ooh, that's a good one. Hold on, let me turn on the second light. Let's see if this destroys my camera whiteout. Better, worse. I think I just completely lit up my paper. That's worse. Okay. I have to adjust the lighting because otherwise the cameras, they just don't cooperate. All right, the NFPA 99 policies on plug-connected portable non-medical electronics. If a non-grounded item is within a patient care vicinity, it has to be double insulated, and the items have to be inspected when they come into a facility. I don't know what else they would want from that. NFPA 99 requirements regarding AC-powered equipment not related to patient care, which include both facility and patient-owned electronics that the patient will touch during normal use, must be inspected by staff. It says just inspected by staff. It does not say inspected by biomed, all right? There's a lot of people out there in this industry think that biomed have to inspect every single toaster that comes in the door. We do not, okay? And that includes like the CPAP machines and stuff. Do not touch them if you don't have to. I mean, trust me. If you touch it, you own it. So medical staff can inspect them to see if they're safe. Further, any improperly functioning equipment must be retired or reported to maintenance. NFPA 99 also provisions that household electronics without grounding conductors may be permitted as long as they're not in the patient care vicinity and as long as they're double insulated. Bam. Oh, jeez. You like the tunes? I'm sorry, guys. I don't have monitors. Well, I do, but my monitors, they would echo really bad. So that's why I have them shut off. Sorry. Normally I look over here and I can see that something's still playing, but I didn't. Explain the requirements of labels for chemicals. Ooh, okay. Well, this one here, we're going to go over this one really quickly. So labeling requirement for chemicals is, first off, the chemicals have to be registered in the material safety data sheet or the safety data sheet. And the label on the bottle has to contain also the chemical name and some of the safety data sheet information. I don't know what else has to be on those bottles. The term label refers to the label on the container. Under GHS, it's required to contain certain elements. These requirements apply whether the label is affixed by the manufacturer or whether the chemical is placed into a smaller secondary container in the workplace. The label must also include the ID of the chemical, the manufacturer's name and contact info, the applicable GHS pictograms, which are, caustic, causes death, those pictures, and applicable signal words, danger or warning, and precautionary statements, measures to reduce risk from exposure to chemical. Something like use safety glasses, Interesting. So that has to be on the label. And let's go ahead and let's pull that up. Boop. All right. Why does that never work right away? Every single time. There we go. All right. Sorry. All right. Chemicals. How are we labeling our chemicals? Okay, right there. This is the perfect example of what they're talking about. So anytime that a chemical is placed into a bottle in a diluted form or non-diluted form, if it's not in the original bottle, you have to label it too, right? Oh, of course it's a tiny picture. Oh well. Anyway, you guys get the hint. It has to have certain information on the outside of the container. So even if it's things like spray bottles, here's a perfect example. People always get hit because of spray bottles, guys. We understand that it's not at full contact strength, but even in diluted strength, you still have to label the bottle correctly. And hospitals get hit on this all the time because they will have certain cleaning bottles and the cleaning crew know exactly what's in the bottle. Sometimes they even write on the outside with Sharpies, but that is not compliant. So there you go. There's a little picture of it, and we're good. All right. Next. Oh, okay. Good one. Define universal precautions. Universal precautions. Here, I'll tell you. Is that blowing my camera out? Cameras are so fussy. Universal precautions. Well, remember that there's two different types. There's standard precaution and universal precautions. Universal precautions are the older style, and standard precautions are the newer style. And I believe standard precautions are for droplet and aerosol, and direct contact is on universal precautions, right? Universal precautions is a term used in the control of occupational exposure to bloodborne pathogens. The premise is that any and all blood and bodily fluids are potentially contaminated with bloodborne pathogens, therefore should be treated as such. Universal precautions is to be employed that people are to wear protective equipment when handling these items, latex gloves and eye protection, and to ensure that all surfaces contaminated with blood are properly cleaned with bleach solution to kill any viruses that may be present. Solid waste may be contaminated with blood, must be contained in a plastic bag to prevent any exposure to those that are handling it. Okay, so that's universal. So universal precautions covers the environment and what do you do when there's a spill. Standard precautions are, well, we're probably going to get into those. That's probably going to be the next card, right? So universal precautions are for every surface, and how do you clean up every single surface? Okay, we get that. Deal. Next. Let's do this. Describe the CDC prevention's standard precautions. How did I know that was going to be the next card? Okay. Well, I guess I should just read it. Standard precautions are a set of infection control guidelines with broader scope than the infection control of the universal precautions. So universal precautions are the older ones from the 1980s. Standard precautions are newer, and they were implemented in 1996. It says they're meant to incorporate the main elements of universal precautions along with body substance isolation to provide a set of precautions more applicable to healthcare environments. Standard precautions apply to bodily fluids and other blood-borne contaminated fluids, but do not include precautions for contact, droplet, or airborne modes of transmission. When standard precautions do not provide sufficient protection, transmission-based precautions are recommended as supplementary measures. Doesn't this seem like a bunch of bureaucratic garbage? Is it just me? Am I really just that annoyed by this kind of stuff? That they couldn't just wipe the slate and be like, okay, here's the precautions going forward. Nope. We're going to create 3 sets of precautions, and you're going to have to remember them. Here we go. Oh, this is a cool one. This is a good one. Outline the role of the College of American Pathologists, the CAP. So, the CAP inspections. CAPs are a very rigorous inspection activity, and it is implemented by the CMS, which is the federal government, and this is how they inspect laboratories. That is the American College of Pathologists, or College of American Pathologists. CAP is a nonprofit organization that serves as primary accrediting agencies for medical and hospital laboratories. CAP conducts regular, every 2 years, and spontaneous inspections of laboratories. It's the spontaneous ones that get you. As soon as they find one little thing wrong, let's say they're just walking through one day, they find one little thing wrong and they start digging. CAP is no joke, guys. Because if they shut down your laboratory, then you have no hospital. Hospitals do not function without laboratories. It says CAP inspections usually include touring the facilities, interviewing staff, reviewing procedures for quality control and sample handling, and reviewing facility records. It's the facility records that get you. Always document things 120% in laboratories, for sure. A says, I'm a biomedical engineering student. Well, welcome, A. Welcome to the party. All right. Next card. Outline the location requirements regarding telecommunications rooms. Woo. Okay. Now this is one that I talked about yesterday. It made sense, but I didn't know a lot of the stuff that was in it. I think it said that your longest comm line can be 90 meters. I think it's 90 meters. And they have to be accessible to the inside of the facility, not to the outside. And also in communications rooms, telecommunications rooms are only supposed to contain telecommunications equipment. It's not a storage area. Let's see what they say. NFPA requires healthcare facilities provide enough telecommunications rooms so that there is no more than 90 meters travel length between data outlet and the TR. So 90 meters is your longest run. TRs must use electrical equipment relevant to support the TRs, and only necessary equipment or fixtures may be inside. There must be a minimum of 1 TR on every floor of a healthcare facility. Now that's one that I didn't remember. Okay, you have to have a minimum of 1 TR on every floor of your facility. And a single TR may service a maximum of 20,000 square feet on any floor. 20,000 square feet. It seems like it's a lot, but I bet you it's not when you're talking a whole bunch of rooms. Okay. In disaster-prone areas, TRs must be interior rooms with no exterior facing walls. No, that's pretty much everywhere, right? Disaster-prone areas. Okay. So the two things that I took out of this card are one on every single floor, and I have to remember that the maximum that they can service is 20,000 square feet. Good to know. I imagine that those numbers are going to be important. Next. Describe the types of personal safety equipment that may be indicated on a safety data sheet for the safe handling of a particular chemical substance. Okay, so your personal safety equipment could be, well, I would assume it could be a lead apron. It's going to be an apron. It's going to be a face shield, eye goggles, heat mitts. It could be non-porous chemical gloves. It would be a gown, a drape. It could be a PAPR, positive airway pressure respirator, or a regular respirator. I would assume that's all. STS often recommend use of chemical protective clothing, eye goggles, splash guards, and air vents should be used when handling chemicals, face shields, and safety goggles, gloves. Gloves should be based on permeability and reactivity to the chemical in use. Personal respiratory equipment may be indicated if a fume hood is not available. Body protection depends on the level of protection needed, and the ranges from rubber aprons to full suits. which are evaluated based on their permeability and leak protection. Closed-toed shoes should always be worn when working with chemicals. All right, I was pretty close on that one. Next. Oh, good one. Good one, good one. Give an overview of radiation protective equipment. Well, it's not really protective equipment, I suppose, but there is shielding, like shielding glass. That is protective equipment. There's also obviously shielding aprons, which include gowns and arm covers and stuff, and thyroid covers. Let's see, radiation protective equipment. I would technically still say your TLDE or your dosimeter are going to be part of your protective equipment. So you shouldn't be anywhere near ionizing radiation without a TLDE badge or a dosimeter. So, let's see what they say. Personal protective equipment for radiation includes lead-shielded clothing such as lead aprons, collars, gloves, and eyewear. Radiation exposure in medical setting primarily comes from RAD. NFPA 99 standards require labeling of spaces that present a radiation risk, radiology imaging rooms specifically. Excess radiation exposure from medical devices must be avoided where possible, so the rooms for X-ray imaging also have to be shielded to prevent leakage to staff and patients outside. It doesn't talk about shielding glass inside. In most rooms that have ionizing radiation, there is some sort of shielding barriers that are portable, so that because these spaces are configurable based on the procedure and based on the patient, there's going to be like shielded glass that comes down, either from a boom, like a ceiling mounted boom. They have shielded glass that comes down to block you, or there's shielded glass panels that roll out on dollies, and you plop them down. That way, there, if you're back here working on a computer, you know you've got extra barrier of radiation protection. It's funny because that is radiation protection equipment. They didn't mention it. Let's see. Next, discuss back office procedures, infection control. That's a good one, isn't it? Back office procedures. Well, for my team, my procedure was anytime you come in from anywhere in the hospital, you stop immediately at the sink and you wash your hands. That was my number one rule. Everybody on my team loved it, and none of them on my team got sick during COVID. We used regular precautions like washing your hands, and we were good to go. You also shouldn't have liquids in certain areas, like operating rooms, you goofballs. A couple of you guys on social media recently, I've seen that you posted photos of yourselves working, like sales reps working out there in operating rooms, and these dumbasses, they posted a photo of them in an operating room with like a can of soda sitting next to them. Fucking idiots. That is not a standard precaution, all right? No liquids in those areas. No food. So anyway, the back office procedures, I would say wash your hands and wear gloves when possible. I don't know. Let's see what they say. Oh, Jesus. Look at this. Okay. Every medical facility should carry out biological risk assessment each year. I am not going to read through this. It says utilize appropriate hand hygiene, number one. Using mechanical pipettes. Everybody uses mechanical pipettes now. Come on, guys. Prohibiting eating, drinking, smoking, storing food in the laboratory, but that also includes operating rooms, you goofballs. Okay, let's see. Utilizing retractable needles and lances. Those things are amazing. I have yet to do a video on the medical technology advancements when it comes to like stick prevention, like needle sticks. But there's some cool tech out there, man. Minimizing splashing and aerosoling liquids, decontaminating possibly infectious materials, packing potentially infectious materials for disposal, maintaining pest management system, ensure all people are trained, ensure appropriate immunizations, yeah, right, making personal protective equipment available, and ensuring an eye wash station is easily accessible. That's what they say. That's back office procedures. That's a poorly worded question. Okay. Next, discuss core measures from the Center of Medicare and Medicaid Services. Oh, Jesus. Okay. Well, core measures. So there is two types of stats that they encourage that people share, and that is a sample from adult and a sample from pediatric. I know that much, but core measures is one of the things that CMS is trying to keep track of, and it's supposed to be reported from every medical facility. Let's see what they say. Core measures are the evidence-based use of treatments to reduce risk of complications. CMS publishes core sets. I'm not reading that. As of 2014, CMS does not require submission of core sets, but recommends that healthcare practitioners report for one adult core set and one pediatric core set. Adult. Pediatric, I'm not going into all those details. It's a bunch of probably not so useful information, but they do recommend that you submit one adult and one pediatric core set. One set of data. Okay. Let's see, is that 2 cards? Yes, it is. Okay, let's see if I can get this. Describe clean agents as defined by NFPA 99. Okay, clean agents. Now, if I remember correctly, clean agents were non-combustible and non-oxidizing gases like nitrogen, helium, it would be carbon dioxide. I believe that that's what NFPA considers clean agents. Clean agents are items, if I remember correctly, that can put out a fire without leaving residue. So let's find out. Clean agents are extinguishants, materials capable of extinguishing fires that are electrically non-conductive, volatile, or gaseous, and do not leave residues upon evaporation. Inert gases, nitrogen, carbon dioxide, and noble gases are clean agents. Got it. Next, explain the methods for describing toxicity and exposure limits for hazardous substances on safety data sheets. Okay, so there was 2 sets of data. One of them is the ETO, and the other one is the HSO or something. I don't know. There's 2 different standards. One of them is when exposed to the substance, 50% of the participants died, and that is a certain level. And then the other one is even when diluted, 50% of the subjects died. Very morbid. Let's see what they say. Explain the methods for describing toxicity and exposure limits. Jeez. Well, okay, I was really close. So they're required to provide all known information regarding its carcinogenicity, that's horrible, known as potential cancer causing. Carcinogenic risks are produced in the NTP report and OSHA. I'm skipping through a bunch of stuff, obviously. Toxicity levels are indicated by numbers called the LD50 and LC50. LD50 refers to the dose, so the LD is the dose, at which 50% of the test subjects were killed, and LC50 is the lethal concentration at which 50% of the test subjects were killed. Jesus. Dosages are typically normalized to include the mass of the possible toxin divided by the mass of the test subject. Wow. Okay. So it says these can be measured as the OSHA permissible exposure limit, the PEL, or the threshold limit values, the TLV. If I'm going to get something wrong, it's going to be the LD50 or LC50. The LD is the dose, and the LC is the concentration that is lethal. I mean, even aspirin. I mean, technically, let's say, so the LC50 and LD50, aspirin itself would have a value because at a certain percentage of the body weight, you take like 1 pound of aspirin, you're probably going to die, right? So I understand what they're talking about there, but still is a little confusing. I'm over it. Next, describe electrical shock hazards, their effects, and appropriate interventions. Okay. They're not really giving me too much to go on. So electrical shock hazards, well, I guess we could talk about case leakage, so or chassis leakage, or touch current, whatever they want to call it this year. So your electrical shock hazards, it's anytime electricity wants to migrate from a device to another body, electricity always takes the path of least resistance, and for some odd reason, you are a lower path of resistance than its own return path, which could happen if you have like an open neutral or something like that, and maybe some fluid intrusion into a device. I have seen it. The electricity has no return path because the neutral is open, because remember, a lot of medical devices have both hot and neutral as fused and switched. So it's entirely possible to blow out a neutral fuse and still have a hot fuse open. To which then, if there is any fluid intrusion into the device, you put your hand on that device, the electricity has almost nowhere to go except for back into you or ground. But that's why we test ground, now isn't it? I don't know what they want for electrical shock hazards and their effects. We could state that infamous like 100 microamps to 200 microamps is enough to cause ventricular fibrillation. Is that what they're looking for? Appropriate interventions. We all know how to stop fibrillation if it happens. Appropriate interventions. Is this going to be a champion for electrical safety? Let's find out. Here we go. Electrical shock can occur when electrical conductors are exposed due to damage and short, causing leakage current through the equipment chassis. Currents between 100 and 200 milliamps, even at relatively low voltages, can cause ventricular fibrillation. All staff should be able to recognize and report shock hazards. In the event of a shock, avoid touching the victim. It should be disconnected at the fuse or circuit breaker, or it should be moved away from the victim with a non-conductive material. First aid includes checking for breathing and pulse, followed by CPR. All right. I was close on that, right? Here we go. Next one. Discuss infection control methods that are important to a medical care setting. Boy, that's a vague question. Discuss infection control methods that are important to a medical care setting. Isolation. Labeling of precautions. I would say using gloves, using drapes and respirators. Washing hands. I don't know. Let's see what they want. Patient care areas need to be cleaned daily, of course. Any patient who appears to have communicable disease should be taken to an exam room as soon as possible. Policy should be in place for cleaning exam rooms and equipment between patients and the end of the day. There should be a clean and dirty utility room for contaminated equipment and supplies so they're not mixed with clean supplies. The proper disposal of needles and sharps need to be in appropriate containers. Hand washing supplies should be readily available. All staff should recognize health exposure risks in the presence of bacteria in the work environment. All employees need to understand the process of disease transmission and the use of standard precautions and how to isolate an infected patient for employees and patient safety. Ta-da! I don't know. I gave the short answer. All right. Next one. Describe the Centers for Medicare and Medicaid Services, CMS. This is the great granddaddy. This is Daddy Warbucks. All right. CMS is the entity of the federal government that provides money and basically socializes American healthcare on the grand scheme. All hospitals would fail if it wasn't for CMS money. We do have a publicly funded healthcare system, whether anybody wants to believe it or not, because hospitals would fail without that CMS money, which is why we have inspection activities and we jump through hoops. Not saying that's a bad thing, just saying. CMS is the great financier of American healthcare. And here we go. Previously known as Healthcare Financing Administration, the HCFA. They also do the CHIP program. It regulates laboratory testing on humans, along with the Department of Labor and Treasury, assists in maintaining health insurance coverage for small companies. CMS combats fraud and abuse in cooperation with federal departments and state and local governments. CMS helps improve the quality of health care for people receiving health coverage via its programs through development and enforcement of standards. How do you enforce standards? By controlling the money, right? If a hospital loses its CMS funding because, let's say, they got a bad Joint Commission response, you will close your doors. And that has happened quite a bit this last year. Next, oh, this is a good one. Next, explain the NFPA 99 definition of touch current. This is the type of question that I would expect on an exam, all right? Because you should be able to know this, and you should be able to know the limits as well, right? You do electrical safeties every single day, right? You should know the current limits, you know, for chassis leakage or touch current leakage or ground leakage. What do they call it this year? So, touch current is the amount of leakage between the chassis of a device and somebody that touches it, right? It's the amount of latent amperage that's waiting to go someplace. Normally, it takes the neutral path back to its source. Or if there's some sort of internal failure, there's also the ground conductor on most devices. So you would have a pathway to ground that way. However, with fluid intrusion, maybe bad electrical connections, sometimes even, as I mentioned earlier, you're going to, with electrical spills, let's say you got fluids inside it, sometimes your fuse will pop for the neutral because the weakest link pops first. And so now the whole device is hot and there's nowhere for it to go except for ground. And if you're touching it, you have the path of least resistance, you get a little bit of that special sparkity spark. So, NFPA 99 definition of touch current is electricity leaking from the case of a chassis of a device into your body. NFPA code defines touch current as any leakage current passing from the chassis of a device which is able to be reached by patients or staff that flows through a path other than the device's protective grounding and other parts of the chassis. So this right here is the number one reason why we, on electrical safeties, we check ohms first for the ground conductor. Because if you have a faulty ground conductor, then you're also going to have a faulty leakage reading. Okay, so we always test the ground conductor first, because if that fails, then why even continue with leakage? So there we go. That's a good question. I would expect that on the test. Next, says explain the function of a safety data sheet and list the key information included. Oh, geez. Well, there's 16 sections on a material safety data sheet. It includes things like the common name for a chemical, the manufacturer, its toxicity, its spill control information, its usage information. I know there's 16 categories of data that's on a safety data sheet. And the simpler chemicals obviously aren't going to have all 16 fields filled, but if it is a dangerous chemical, then you're going to have a very big safety data sheet. Here we go. The 16 sections are the identification, the hazard identification, composition information on ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage requirements, physical and chemical properties, exposure controls and personal protection, stability reactivity, toxicological, so it's toxicology report, ecological information, disposal considerations, transportation information, regulatory information, and other information. That's a lot of stuff, isn't it? See, my camera is not, it's not playing well, is it? There you go. It's quite the list, guys. Next, we're getting through them, guys. We are most of the way done. Describe some types of protective equipment used in healthcare environments for preventing infection. Describe some types of protective equipment used in healthcare. Okay. We use positive airway protection, PAPRs. So that's respirators. We use those. We use eye protection. They got eye shields. We got face masks. We've got gowns, protective gloves. We have, technically, the equipment would also involve the room. So we could have negative airflow rooms, and those are rooms that have internal HEPA filters, and it's whenever you open the door, there's a negative pressure, so it's a negative pressure room. We have those. We have shielding, but that's not for infection. Technically, the equipment would also be the protective needles and stuff that we talked about. So this is kind of a vague answer. It's pretty big. PPE, specialized clothing, yada yada, gloves, gowns, eyewear. Pretty much everything I just said. Yep. Everything I just said. Standard PPE. Describe the indicators and methods of basic infection control measures. Describe the indications and methods of basic infection control measures. The indications and methods. This is another one of those poorly worded questions. Obviously, basic infection control is to contain any blood, clean surfaces, to use PPE, and wipe down equipment in between patients. I would think that is all standard. Standard infection control measures are designed to prevent transmission of microbial substance. Yeah, they're talking about PPE, and if you have tuberculosis, SARS, or VZV, they should be in a negative air pressure room. Yep, they talk about negative pressure rooms down here. They also talk about how staff should use N95 masks For disorders such as influenza and other infections spread by respiratory droplets, basic surgical masks should be worn. For precautions in the presence of diseases transmitted fecally orally, gowns and gloves should be used and contact limited. Laboratory coats are not a substitute for proper gowning. Good to know. The next, discuss appropriate accreditation, certification, and recognition options, the DNV and ISO. Okay. This is also a really poorly worded question because technically Joint Commissions should also be on this list. So describe appropriate accreditation, certification, and recognition. And it shouldn't be options, all right? First off, a hospital, they can have an ISO rating, but that is not compliant for CMS, all right? For CMS, you know, Granddaddy Warbucks to give you money. It has to be, as far as I'm aware, DNV, I believe it used to be AAAHC, and then Joint Commission. So there's like 3 different options. DNV is an ISO, that's the weird part about this question, is DNV is actually an ISO type of program, ISO certification, which means you have to have a quality control. Every single year they do, there's some sort of internal audit. So there's big audits and there's little audits, and the big audit is like every 2 years and little audits are every year. But your own quality assessment team that's locally, which means they're hospital employees, they have to go around and every single day or every single month periodically audit departments of the hospital. So that's the DNV. ISO certification is a whole nother thing. I should do a whole video on it because ISO certification is basically a quality assurance and improvement process. And it means that you have processes for everything that you do, and you have those documented, and you follow those processes. That's basically ISO certification. And there's different levels. Like we have ISO 9001, it's pretty standard, but it's a low level. You have ISO 13485, which is for medical equipment manufacturers and repair places. I mean, there's a bunch of different ISO certifications, but DNV's also, they're gaining market share against Joint Commission, so they have an interesting program. Let's see what they say. DNV is accredited organization, yada, yada, yada. Pretty much all the stuff that I just said. They talk about the different programs within DNV, like managing infection risk, primary stroke, comprehensive stroke, acute stroke, hip and knee replacement, and they do a bunch of other things. But ISO is like I said, it's like a quality management, quality assurance type of program. It's not a substitute or an option for Joint Commission DNV. So that's what makes it a weird question. Next, overview the requirements for medical gas and vacuum systems. Okay, so medical gas and vacuum systems, they have to have valves and gauges in zones, and they have to have clear labeling on every single one, which dictates what it is. Is it carbon dioxide, nitrogen, oxygen, med air, vacuum, WAG, waste, anesthetic gas. So you have all these lines. They have to be labeled, and they have to have sole connections, which means that without adapters, you have one type of keyed connection. I know that medical gases, they have to be tested for purity and flow, at least annually. There's not too much else I can say about it. That's probably as good an answer as you're going to get. It says the standard applies to general anesthesia, the standard applies to general anesthesia, deep sedation, that is situations which gas or vacuum leakage may cause major injury or death, and or gas vacuum systems for use with patient care vicinity. It requires that gas cylinders adhere to DOT, TC, and ASME regulations. Feature content-specific outlet connections, like I said, specific connections that are keyed only for a certain type of gas. Using incorrect color fittings, using adapters, or using hoses of an incorrect color are all big no-nos, right? It's color-coded, and every single screw-down connector is keyed either in shape or size, diameter, who knows. Systems must incorporate appropriate piping and component redundancies to prevent single fault failure. Feature appropriate alarms, labeling shutoff valves, and pressure vacuum indicators, and maintain an inventory of regular inspections. So that's the one that I didn't add into it, is that they do have to be periodically inspected annually. Next, identify common symbols used in the global harmonization system convey hazards. So this is going to be what? The ecological, this is going to be the explosive, the ball with the lines coming off of it. It's going to be the corrosive symbol. I think there's one for oxidizer. Maybe one for compressed gas. Let's see. There we go. Yep. Health hazard, gas under pressure, reactive, flammable, oxidizer, environmental hazard, poison, corrosive, sensitizer, irritant. Boy, this camera is just a peach, isn't it? It's horrible. Horrible, guys. There you go. Nope. All right. We're getting down. We're the last couple cards, guys. Define bloodborne pathogens. Okay. Bloodborne pathogens are any type of what's the most generic answer I could give? Bloodborne pathogens are any type of pathogen that is in a bodily fluid, and it can be transmitted in a bodily fluid. They're disease-causing agents that can be transmitted from one person to the other by contact with the blood or bodily fluids. And then they talk about what they are, you know, Ebola, hepatitis, etc. It says employees may be at risk for infection by bloodborne pathogens while administering first aid. There's a concern because the diseases that are transmitted are very severe, and they have often fatal consequences, and there's usually little to no cure. Nasty stuff, guys. Nasty stuff. Discuss types of biohazardous waste and disposal methods. Well, biohazard waste, there's actually quite a few of them in there. You obviously have blood and bodily fluids. You have solid waste. There are sharps, which are a biohazardous waste. There's consumables, which are contaminated. There's also linens. I do know that if linens have dried blood on them, then they can just be put in a bag and then they can be thrown in the trash if necessary. But if there's actual liquid blood on things, then it has to be isolated and put in its own bag and disposed of properly as a biohazard waste. Sharps are picked up by contracted companies usually and handled through incinerators, usually. Hazardous wastes include liquid waste, soft materials, and sharps. Liquid wastes include bodily fluids such as saliva, blood, and urine. Biohazardous spills should be called to attention of staff and trained using correct procedures and tools. Hazardous soft materials include those that absorb and should be contaminated by liquid waste, like patient bedding, bandages, and towels. It says these materials may be disposed of in leak-proof bags to be cleaned or disposed of by specialized facilities. Sharps, including needles and scalpels, which can puncture skin and become contaminated with blood, as well as sharp debris such as broken glass, metal, or plastic shards, Procedure for sharps is to deposit them in properly labeled containers to be collected and disposed of by medical waste. Oh, some good ones, good ones. All right, here we go. Now this one here, they didn't give a good enough answer in the study guide, so I'm pretty sure that it's not going to be the correct answer here. So Safe Medical Devices Act is, it's your responsibility, everybody's responsibility who's around medical equipment when a patient incident is involved, especially when a patient is injured. You're required to relay that information both to the FDA and to the medical equipment manufacturer. And that's why whenever you call a manufacturer and you say you got to return a device for repair or whatever, they always ask you those generic questions like, was a patient involved? Was there a delay in patient care? You know, those questions they ask you are because of the Safe Medical Device Act. Now, I thought also the Safe Medical Device Act required certain devices to be tracked, like defibrillators. I thought for sure it was the SMDA that required those items to be tracked. Let's see. It says that the Act designates reporting requirements to track adverse events related to medical devices and was amended in 1992 to require additional information in medical device reports. This includes reporting any deaths related to medical device to both the FDA and manufacturer and any other serious injuries to the manufacturer, otherwise to the FDA, and requires annual summaries of submitted reports. Although the reports mainly come from manufacturers, medical device reports are also required to come from device user facilities, healthcare providers, when applicable. If you have a patient incident event, normally you are supposed to report that. Most hospitals choose not to for liability reasons and culpability reasons. They would rather sweep it under the rug. But according to the Safe Medical Devices Act, it is your responsibility to report those issues. All right. What's the difference between hazard communication and globally harmonized system, GHS? Oh, jeez. This is one of those questions that I'm just going to be honest with you guys. I don't care. I'm sorry. I don't care. This is a dumb question. Difference between hazard communication and globally harmonized GHS. I'm just going to flip to the back because who cares? Hazard communication refers to OSHA hazard standard found in 29 CFR, yada yada. The hazard communication standard governs the requirements to notify workers of chemical hazards faced to work and provide information on protection from hazards. GHS refers to an international standard developed by the United Nations to guide hazardous chemical labeling, warning systems, safety data sheets, etc. So GHS is the granddaddy of labeling things and safety data sheets. Meanwhile, hazard communication is an OSHA standard, right? Ugh. All right. Next, we only got a couple more. List and describe signal words used by a globally harmonized system to convey a degree of danger. One of them was hazard and one of them was warning. I think one of them is hazard and warning, right? Oh, danger. My bad. So there's danger and warning. Danger is more severe. Warning just means be aware of something. We get it. Next. Describe how to dispose of first aid materials contaminated with blood. Ooh, good one. Well, traditionally, if the blood is wet, then it should be bagged up and disposed of with biological waste. And if the blood is dry, then it can be bagged up and disposed of with the regular solid waste trash. It says here, during the course of administering first aid, you're likely to generate waste contaminated with blood. It says regulated waste, which is contaminated with blood, or that is liquid or free-flowing. This regulated waste must be closed and contained. However, if there's small amounts of blood on first aid materials such as gauze pads, band-aids, or wound dressings that do not contain free-flowing blood, these items can be placed in a plastic bag, then placed in regular trash and disposed of with regular solid waste. That brings us to the final card, guys. Last one. Identify the Joint Commission. These guys, they saved the best for last. The Joint Commission. It's just a regulating agency. They do inspections every 3 years, and it's a very expensive endeavor. And by them creating certifications, you can get your daddy Warbucks money from CMS. Now, the Joint Commission, I know that they make all of their findings public. So if you do poorly on that survey, it's out there for everybody to see. And there's no going back from that. Once you do it, there's no going back. So, Joint Commission, yep, they have a whole bunch of stuff that they go over in a medical facility. And everybody's afraid of them. They say they're not for profit, but they get paid like hundreds of thousands of dollars to inspect your medical facility. Reasons, right? Not for profit, of course. Anyway, guys, there we have it. That is, we actually went through quite a few cards. Now, I didn't have too many gotchas in there. That is a good sign. That is a really good sign. I kind of dig this, going through the training materials and then covering the cards the very next day. I really dig that because it gives me a refresher, helps me remember, like where am I messing up? What can I do better on? This one here, I've run several biomed shops over my career, and I've been a manager or senior tech for over half my career. So I've had to deal with these quite a bit. I've been an EOC voting member for 5-6 years of my career. So I've dealt with a lot of this stuff for years. The terminology, the specific numerics and stuff like that, things that probably would be on the test. Good things to remember, and I feel pretty confident in that one. So I believe my next one is going to be on electronic principles. So here's where I have to come up with a decider. Like, do I want to use the study guide for electronic principles, or should I read the study guide and then just give a class on electronics, because that's my bread and butter anyway? I don't know. We'll see. But anyway, guys, that's it. What's the time now? 7. We did it 1 hour? Yes, folks, that's what I'm talking about. That's a good study session. Anyway, guys, hopefully tomorrow will be the next one, and if it's not, it's because I'm trying to come up with something better. I do believe the next topic we're going to cover is electronics. So I'll see you there, next study session, and if you guys have any questions, go ahead and write them down below, and I will see if I can answer them. And if anything, maybe we'll do a whole special episode talking about whatever topic you guys point out. All right.